Hey guys, so welcome back to yet another video. In this video, we'll be trying to solve the 509th Leetcode problem, that is the Fibonacci number, okay? The Fibonacci numbers, commonly denoted by f of n, forms a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, okay? So basically, the first number is 0 in the series and the second number is 1. So given n, you have to calculate f of n. So basically, like if the value of n is 4, you are supposed to calculate the fourth Fibonacci number. Similarly, if it's 5, you are supposed to calculate the fifth Fibonacci number, okay? So now, like there are two ways of solving this. You could either solve it using recursion, or you could solve it using iteration, okay? Now, like I'll be showing you both the methods. Let's just hop on to the whiteboard real quick. Okay, now let's actually note the series down first. Okay, so the series goes something like this, like according to what they said. It starts with 0 1, right? So 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and it goes so on. Okay, like it keeps on going. So now the first method I'll be talking about is the iterative approach, okay? How you can solve this without recursion. So now in the iterative approach, we will just get each Fibonacci number, and we also have n, okay? So basically if n is 4, we'll be keeping on going from 1 till 4. We'll keep on finding the Fibonacci numbers from 1 till 4, and when we reach 4 we can output the last number we found. So now let's see what I mean by that. Now we could make a base case, okay? Now the base case, as I mentioned, will be the first two numbers. So now if n is equal to 0 or n is equal to 1, okay, now this will be our base case. We can return n, right? Because if n is 0, the 0th Fibonacci number is 0 according to them, and the first Fibonacci number is 1 itself. Okay, so yeah, now we'll be having two variables, okay, x and y. So now x will be equal to 0, the 0th Fibonacci number, and y will be equal to 1, which will be the first Fibonacci number, that is 1. Okay, so now we'll be having a for loop beginning from 2 till n plus 1. Now why we are beginning from 2 is we already covered the case in which n is 0 and in which n is 1. Okay, so now we'll begin from 2 and go till n plus 1. Okay, so now we'll have a for loop as usual. We'll have for I in range, then we'll have 2 comma n plus 1. Okay, so now what we'll do here is we will just calculate the Fibonacci number using x and y. So we'll have a variable called z, which will be equal to x plus y. Okay, now we'll update the value of x and y. Now x will get the value of y and y will get the value of z, right? Now this is how we get the normal Fibonacci sequence. And then when the loop breaks, we can just return z. Okay, now I'll also give you an example. Okay, now in case we want to find the fourth Fibonacci number, that is 3 in our case. Okay, so now x is 0 and y is 1. Now z will be equal to 1, right? Because 0 plus 1 is 1. Now x will be equal to y. Now we know for a fact that y is 1. So now x will get the value of 1 and y will get the value of z. Now even z is 1, right? So now both x and y will be 1. Okay, let me just interchange this. Both x and y will be 1, and this is when 2 is there. Okay, so now when the for loop runs again, it will go to 3. Okay, now z is equal to x plus y is 1 plus 1. Now z will be equal to 2. Okay, now y will be equal to y, x will be equal to y. We know that y is 1. Now x will remain as 1, but y will get updated to z. We know that z is 2, right? So we will put 2 here. So now we can again update the values. The value of x will remain as 1 and the value of y will get updated to 2. Okay, and that's basically it. Now we can just erase all this off. Now the for loop will go to its fourth iteration, okay, because we want to find the fourth Fibonacci number. So now it will go to 4. So now after this particular iteration, like the loop breaks, right, because n is 4. Now z is equal to x plus y, that is 3. Now x will get the value of y, that's 2, and y will get the value of z, that is 3. And that's it. Now the value of I in the for loop will be 5. So the loop breaks. And then we can return z. So now 3 is our answer, which is the answer we wanted, right? Because the fourth Fibonacci number is 3, right? 0, 1, 2, 3, 4. Okay. Now this was the iterative approach. Okay. Now let's learn about the recursive approach and how we can solve this using recursion. Okay. Let me erase all this. Okay. Now let's say, for example, we are searching for the 3, 4, 5, 1, 2, 3. The fifth Fibonacci number. Okay, let's say we are searching for the fifth Fibonacci number. So now if you guys don't know recursion already, like I link a video in the description down below and like you can learn from there, but like I will not be going like too much in detail, alright? So now we know for a fact that every Fibonacci number follows a particular pattern. Now what is the pattern? Okay, now let's say for example the name of our function is f, okay, or let's say for example fib, which will take in n as an argument. Okay, now we know for a fact that f of n is equal to f of n minus 2 plus f of n minus 1, right? Let's erase that, plus f of n minus 1, right? Because let's say f of n, it is 5, it is equal to n minus 2, that is 2 plus 3, right? And that will give you 5. So now this is the way we find every Fibonacci number. Okay, now recursion basically means we will keep on calling the function until we get our desired output. So now we'll be having a piece of code like this. Okay, now to do this main function, we will be returning something like return fib of n minus 1 plus fib of n minus 2. Okay, now what will this do? Okay, so now let's consider the third, fourth, 0, 1, 2, 3, 4, 5. Okay, now let's consider the fifth Fibonacci number, that is 5. Okay, now the fifth Fibonacci number is equal to f of n minus 2. 5 minus 2 is 3, right? Plus f of n minus 1, that is 5 minus 1, that is 4. Now we'll keep on calling this function until we get our answer. Now do we know the value of f of 3 and f of 4? No, we don't know the value. So now we'll again call the function. What is f of 3? F of 3 can be defined as f of 3 minus 2, that is f of 1, plus f of 3 minus 1, that is f of 2, right? Now similarly, we don't know what f of 4 is, so we'll again call this, which will be f of 2 plus f of 3, right? Now we again, okay, now we know the value of 1, right? Because the value of 1 is 1 itself, because like we mentioned that here. Okay, like don't forget we have this statement right here. Now this statement is called a base case, and what we are doing now is called the recursive case. Okay, now we know the value of 1, but we still don't know the value of 2, so we'll keep on going on. Okay, now the value of 2 will be f of 2 minus 2, that is 0, plus f of 2 minus 1, that is 1. Now we know the value of both f of 0 and f of 1, right? Okay, now again the same thing, f of 2, it will be the same thing. Okay, now f of 3 will be equal to f of 3 minus 2, that is f of 1, plus f of 3 minus 1, that is f of 2. Now again 2 will have the same answer. Okay, now if you see, we like drew this simple f of 5 all the way down to its base, and now we can recurse back to the answer. Okay, what is the value of f of 0? F of 0 is 0, f of 1 is 1, f of 1 is 1. Okay, now what is the value of f of 2? F of 2 is 0 plus 1, that is 1. Okay, now all f of 2's will get the value of 1. Now what is the value of f of 3? F of 3 is f of 2 plus f of 1, that is 1 plus 1, that is 2. Okay, Now the value of f of 1, we already know it's 1. Now what is f of 3? F of 3 is 1 plus 1, that is 2. And f of 4 is 2 plus 1, that is 3. And then finally we can get the answer of f of 5, that is 3 plus 2, which will give you the answer as 5, because the fifth Fibonacci number is 5. And that's how you solve this problem using recursion. Okay, so now let me code the whole solution. Now I'll be first coding this out using the iterative solution. Okay, now if n is equal to 0 or n is equal to 1, I want to return n. Okay, now I'll be setting up my variables. X comma 0 will be equal to 0 comma 1, the first two numbers in the series. For I in range till, from 2 to n plus 1, now z will be equal to x plus y. Okay, oh, it's not indented. Okay, now you have to update x and y again. X comma y will be equal to y comma z, right? Because x will get the value of y and y will get the value of z. And when the loop breaks, we can return z. Now this is the iterative solution. Let's see if this works. We are iterating through every number in the series. Okay, let's see if it works. And there you go, it works. Let's submit. And there you go. That's how you solve this problem using the iterative solution. Okay, now I'll be using the recursive solution. Okay, now it is recommended that like you don't use recursion for this question. Now I will say why. Okay, now for the recursive solution, the only change I have to do is I have to return self.fib, right? That's a function of n minus 2 plus self.fib of n minus 1, and that should be it. Let's run the code and see if it works. There you go, it works. Let's submit. Okay, now as you guys can see, like why we don't use the recursive solution for this. The recursive solution takes 808 milliseconds to like execute, whereas my iterative solution takes only 20 milliseconds. Okay, so now this is like not all efficient. So like we would like normally go for the iterative solution only. Okay, so now that's how you solve this problem. Hopefully you guys got the idea. If you have any doubts, do leave them in the comment section down below. And that's it for this video, and I'll see you in the next one. Bye.